Hi, so this is the problem explanation for the assignment number 3, ANOVA for biostatistics. The prompt of the question is as follows. A published paper compares the lengths of 3 different bird species, A, B, and C. An ANOVA test rejects the null hypothesis A equals B equals C at P is equal to 0.0001. Your colleague shows that paper as proof that A and B are significantly different. Give at least one reason that he may be wrong.
What is ANOVA? ANOVA is a test that determines if there is a significant statistical difference between groups. An ANOVA test is a way to find out if a survey or experiment results are significant, and in other words, they're to help you figure out if you need to reject the null hypothesis or accept the alternate hypothesis. The null hypothesis is accepted if most of the variance is within group, and the null hypothesis is rejected if most of the variance is between groups.
So this slide is an explanation of what the prompt is discussing, and later we'll be discussing the reasoning and the conclusion for the problem. Using a significance level of 0.05, we know that any p-value less than 0.05 results in a rejection of the null hypothesis. In the case of this problem, however, the p-value was 0.0001. That means that we would reject the null hypothesis. And in this case, the null hypothesis would be that there's no difference between the bird species lengths, and that that most of the variance of length would be within the groups. So the values here would be equal to one another, the mean values, A, B, and C. However, in the case that of the case in the prompt, we land on the alternative here, and in that case, A, B, and C are not equal to one another. So at least one species has a different length, mean length, compared to one of the other two. Or you can also say that most of the variance was between the groups rather than within the groups, as in the null hypothesis. So the ANOVA can't really explain what group is different, but it lets you know that there are statistical differences between the groups, or that at least one group is different from the two.
If the F-score is much greater than 1, the variance between the groups is most likely the source of the variance in the total study. To be able to determine which specific groups differed from each other, a post hoc test would need to be completed. To find out which group the variance originated from, a multiple pairwise t-test comparison should be conducted using Bonferroni correction and adjusting for type 1 error by adjusting the significance level, which would be 0.016. And in terms of the F crit, we got 2.99, which ends up being less than F calculated. So we rejected the null hypothesis at a p-value of less than or equal to 0.05.
So conclusions, what we don't know is that where that difference is. That is why our colleague's statement may be wrong. We cannot conclude that there is a difference between group A and B using just the outcome from this ANOVA. The null hypothesis will be rejected even in the case where the difference between the means A and B may not be significant, but still significantly different from C. There is a possibility that in a given statement is correct, but it cannot be proven without further analysis is being performed.